Hello friends, in this video we are going to discuss about the singly reinforced beam using the Excel sheet. We are going to discuss here how we use and how to formulate insert the formulas in the Excel sheet so that it will helpful in the manual design of the beam. Okay, so here we are going to design the beam these are the given data are there. Okay, for these given data I am going to I am going to design the beam, singly reinforced beam. Okay, and I think you all know what is the difference in the singly reinforced beam and a doubly reinforced beam, right? So we are going to design as per the IS 456 2000. Okay, so what are the given data here there? Characteristic strength of the concrete is 25 Newton per mm square. Characteristic strength of the steel is 415 Newton per mm square. Width of the beam is 300 mm. Depth of the beam is 500 mm. And clear cover, it may be given or you can assume it from 25 to 50 mm for the beam. Right. From this we can use the he has given the 30 mm for clear cover. And he has also given the moment at the center. Moment at the center as 100 kilonewton meter, and shear force is at the support is 100 kilonewton. So from this we are going to, these are the given data. Okay. Next step is what? First I will assume the diameter of the bar. It can be used for the main reinforcement as 16 mm. So it can be used for the later words. And next we are going to calculate the effective depth. So effective depth, how it will be calculated? Yes, D is equal to capital D minus S D dash. So what is capital D here? Capital D is the total depth of the beam minus clear cover. So how I can calculate? So is it first to any calculations, if I want to start in the Excel sheet or any cell, it will be started with the equal to sign. Okay, so using this, first I have to start with the equal to and then click on the first capital D value. So this is the depth of the beam. So here I have clicked, okay, one click, minus, using the minus sign, 30 mm. So this is, you can see here, you can see the F6 minus F7 means F column 6th row. So this is the F6, that is depth of the beam, and F column 7th row, this is the 30, that is the clear cover. So these are the notations which are mentioned in it will be visible in the area, and depending along with this you are getting the different colors. Right, so these color are also indicating, color code also given in this, so that if a number of selections are more, it will be very easy to identify the color indication. So this is how our Excel sheet will be designed. So here if I entered it, then it will be calculated easily. So what we'll do, check it once again. So if I want to change, if I make any changes here from 25, so you can make a note here, it will be changed automatically. No need to again you do to calculate back calculation. So it will be automatically calculated. Say this is 30, again 370. That is, I am giving these cells as a reference cell, so that whatever the input I have given the input or whatever the values I write in these values, these cells, here it will be calculated depending upon these values which are present in the both to these cells. So this is how our Excel sheet is working, guys. Okay, next is XU max by D. So it is available in our IS code, that is at the clause number 38.1. So for FY 415 steel, it is XU max by D value is 0.48. So you can see here at the 38. See here, it is for Fy value, XU max by D value is For FY 415 it is 0.48, for 250 it is 0.53, and for 500 0.56. So depending upon my FY value, I have to consider this one, consider the XU max by D value. Okay, so after this again next step is our MU limiting formula. We have the MU limiting formula, it is 0.36 into XU max by D into bracket 1 minus 0.46 into XU max by D into FCK B into D square. So this all formula, in this whatever the here I know the XU max by D as I have just calculated, and then I have the FCK value, I have the B value, I have the D value. So depending upon using this I can calculate. How to calculate? I will calculate here. So first is equal to sign MU limiting. So MU limiting, how we calculate, is equal to 0.36 into S into XU max by D. So how to calculate? You can use the cursors, you can use the mouse, or you can use the arrow key so that you can easily move it wherever you want. XU max by D into bracket. See, whenever we are using the Excel sheet, we have to see that number of brackets which are opened, so that much number of brackets have to be closed properly. Otherwise, what will happen? You will get the wrong answer. 1 minus 0.542 into XU max by D bracket complete into FCK. FCK is 25 into B is 300 into D is here whole square, so whole square. So this is how we can use and then enter it. So this is in Newton per mm. To make it in kilonewton per meter, so this divided by 10⁶, it will give me the value of 228.57 kilonewton meter. So this is the MU limiting. So now this is less than my MU, right, which is given, since this is less than MU, so I can say this is a singly reinforced beam, right. So here also I can use the one more function called if function, right. If I want to, here what I am doing, if it is a MU is greater than this, in that case what would have written here? It should be written as the doubly reinforced beam. Calculation should be as per the doubly reinforced beam, right. So how you get to know? By just always by looking at this whether it is correct or wrong, right. So just if I use the if function and I will write a sentence like this, since it is a less than MU is less than MU limiting, it should write a singly reinforced beam, or if it is MU is greater than the MU limiting, in that case it should write as a doubly reinforced beam. How I can do it? Using the if function. So if function, what it is doing? If function, what it will do? First it will analyze the formulas first. So whatever the formulas I am given, so that is MU is greater than MU limiting, that means this value, it is greater than this value or less. First it will analyze it, then it will give me a true value, that is true function. If it is true, in that case what should be written? If it is fails, so in that case what will be written? So it can be used for the message box also, or you can use the formulas in the form of formulas also. Okay, so now I am using here for the shear. What I will write is equal to, how to write, if these are the inbuilt functions which are available in the Excel sheet itself. If is equal to my mu limiting, so this is less than mu, comma, in that case double inverted comma, yes, singly reinforce, it should write as a singly reinforced beam, or if this function fails means if mu limiting is less than mu, so in that case it should write doubly reinforced beam. So it should be depending upon the whether I go for the singly reinforced beam or doubly reinforced beam. Sorry, it should be, if it is greater than this, right, it should write singly reinforced beam, and then if it is a singly reinforced beam, in that case whatever the reinforcement I have to provide, it fully on the bottom side itself, bending moment requirement of the moment for the bending moment. So in that case, for the calculation of the area of steel, right, next step is our calculation of the area of steel, right. So here next step is calculation of area of steel required. So in that case, for that I have the formula AST is equal to 0.5 FCK by Fy into B into D into bracket 1 minus square root of 1 minus 4.6 into mu divided by FCK BD square, right. So this is my formula. See here, here in the Excel sheet, to calculate the square root, right, I have the function, that is SQRT function I have to use, SQRT into bracket. So whatever the into bracket it is there, so it will be fully considered it as the within the square root itself. So this is from up to this, all the thing it will be within inside the square root. So it will give me the value. So how to calculate? Again, it's equal to 0.5 into FCK. Again, click on the FCK divided by Fy. Okay, FCK into Fy into B into D into B into small d into bracket 1 minus square root of SQRT, right, 1 minus square root of, so this is the CS SQ. If I write it, you can see here the values also. You can just double click it so that it will be opened, SQRT into bracket 1 minus, right, yes, 1 minus 4.6 into mu into 10 raised to 6. Why I have written the 10 raised to 6? Because where all the values in Newton per mm, right. So except my mu is in kilonewton meter. So to convert that kilonewton meter to Newton per mm, so I have taken the 10 raised to 6 divided by, I will open one more bracket because for the denominator part, FCK into again B into, next is D whole square BD square C. Here when I am opening the different number of brackets, it is given the different colors. So each color indicating its own bracket. So see here, for this bracket, if I close here, so it is color is same, right? For the next bracket, since this color is end bracket is not available, it is not closed yet. So it has given the same color next. So one more bracket is open. So this is the last bracket is last and first bracket is always in the black color, and after that there are different colors, various colors it will be available in the bracket opens. So after that just enter it. So this is the amount of reinforcement required, that is 637.42 mm square, right? So number of bars required. So how I have calculated this? How you calculate this? AST required, yes, number of bars is capital AST divided by small ast. So capital AST is what? Area of steel required divided by area of steel of single bar. So here first as here I have already assumed the diameter of the bar, that is 16 mm, right? So using this I can easily calculate Shear. How I calculate it? So now we are going to start here to calculate the number of bars required, capital AST by small ast. So capital AST is this my 637.47 divided by small ast. How to calculate? Using the formula pi pi, okay, pi into pi by 4 into d t square, that is diameter of the bar 16 square, okay. After this enter. So I require 3.7, so I can provide, okay, 4 number of bars, 4 number of dia bars at 16 mm, okay. So this is how I can calculate. Area of steel provided is AST provided is equal to, how can I calculate? 4 into pi by 4 into 16 square. So this is what our area of reinforcement you provided. So this is how I have calculated the area of steel. Next step is shear force calculation. So to calculate the shear force calculation, I require the percentage of steel provided. So how to calculate? I have the formula, that is percentage of steel is equal to 100 AST provided divided by BD, right? So as per the IS 456, right? So using this again I have to given this AST provided into 100 divided by 300 into D. So this is how I can calculate. This will be my 0.57, right? So this is my PT, right? So from PT I have to calculate the tau C using the IS 456. In this I have the table design of shear. So these are the percentage of steel, and these are the for the imprint for different grade of concrete tau C, right? So for our grade of concrete is 25. So in that case I have to look after the 25 column, and I have got the PT as 0.57. So it is my point PT is within 0.5 to 0.75. For 0.5 I have for 25 0.49. So here I have to write 0.49, and 0.75 it is 0.57. So it is there already. So after this, so this is the difference, it is there. This is this difference, and this is the difference. So to calculate this, I have the tau C using the using the different methods, we can calculate the variation of the tau c at 0.57. So how to calculate? Is equal to 0.49 plus difference of this tau c divided by this one. So into this. So this is what I have calculated. So how I calculated difference of this? So first 0.549 plus difference of these two, both difference of these two divided by difference of these two into difference of 0.57 minus 0.5. So this is how I have calculated the tau c, and this will be my tau c. Okay. Tau v can be calculated as Vu by B into BD, right? Using this I can calculate the tau v. So our Vu is what? He has given the 100. He has given the 100 kilonewton. Since it is a kilonewton, I will convert it into Newton per meter. Newton 10⁻³ divided by BD. So B is 300 into D is 470. So is equal to, this is my tau v. So to calculate the shear reinforcement, I have the formula from this. I have the formula Vus is equal to Vu minus tau c into BD. So Vus equal to this one shear, whether this is more or not. Since if it is a less than tau c, so no reinforcement is, shear reinforcement is required. If it is more than this, so here shear reinforcement is required, right? So from that case, it will be Vus is equal to, it can be calculated as Vu, that is 100 minus tau c into B into D. Here I have to make this in Newton into 10⁻³. Yeah, this will be my Vus for this force 27 kilonewton or 27,734 Newton. I have to calculate the shear force, shear reinforcement using the 2 LVS, that is 2-leg vertical stirrups, and 8 mm dia. I have the formula SV is equal to 0.87 into Fi into ASV into D by Vus, right? So what is ASV here? ASV is what? Area of reinforcement for the shear reinforcement. Since I am having the 2-leg diameter, so it will be like this. So I will calculate ASV is equal to SV equal to 0.87 into my Fi is 415 S into bracket 2 into pi by 4 into bracket. See, this here diameter of the bar is varied. So here it is 8 mm for shear reinforcement square into D. D is 470 divided by Vus. So this is in mm. So spacing required is 630. So as per this rule, I have the, it should be minimum of 300 or 0.7 of D, that is 0.7 of D or whatever the value it is there. So since it is more than this, it will be 300. So this is how we can calculate the minimum spacing and the stirrups required for the shear reinforcement. This is how you can calculate using the Excel sheet. So using this, if I change this one moment just here, if I got the 150, so in that case again no need to calculate once again. So just you can check it here. So what is your mu? It is singly reinforced. So AST, whether you have corrected, it is 4.4, it is there. So here you can change it for 5, and AST it is there, and then you go for the PT. So from PT to here you just change the values here, so that it will be automatically calculate the tau C, and then it will calculate the tau V. Automatically it will be calculated, and then you go whether the shear reinforcement is required or not. Like this it can be easily calculated. Yes, so this is how you can easily calculate. Okay, thank you.